going to be learning about Strands Agents and building autonomous, self-improving AI agents. So my name is Aaron. I'm a principal engineer in the Agentic AI org.
I'm Çağatay from the same organization as a research engineer.
Yeah. So today, by the end of this session, we will go through watching an AI agent, read its own source code, create new capabilities while it's running, and then we will deploy it to production, a self-evolving agent. And this is not theoretical. We have a GitHub repository we'll share with you as well. It's all working code. Feel free to follow along or after the session as well. So we can jump in. So we had this, this poll-up just as everybody was coming in here. We got some of the results here.
So we have such a mixed results.
Very mixed results.
I vote for, I'm new to agents, so don't mind me. Thanks for this voting. Looks like we have people build simple workflows, use framework like Strands Agents, new to agents and production agent systems heavily, right?
Yep. A couple of people even building autonomous agents already.
We love that. Perfect.
Yes. So thank you for those.
So
what are we building today?
So we have a GitHub repository. You can scan the QR code, open in your GitHub, and follow along with us over the commits. We have 6 commits to share with you. Each individual slide have own code, so you can also follow us while we're explaining the ideas, and you can inspect the code and run.
Yeah. So in this repository, and you can talk to us outside afterwards as well. We'll be around. But in here, this is the code that we're going through today. You'll see several commits in there, as Çağatay mentioned. Each of those commits builds up from the last towards our final self-evolving agent. So feel free to follow along there. The agenda for today. So we'll start with a very basic agent, looking at the poll results. Shouldn't be anything revolutionary to most folks here. We'll start with a very basic agent, and we'll start gradually introducing more and more autonomy. First of all, we'll have the agent build its own tools. So, folks who've built agents before, agents are a couple of things. One is the model, one is the tools. And these tools, often we write them ourselves. We build Python code or we build an MCP server. What we're doing here is having the agent actually build that tool and test that tool itself. And if the tool fails, it can correct the tool's implementation and continue from there. Once we have that, we will have the agent update its own system prompt. So again, with the work that Çağatay and I have done in Kiro and QDeveloper, for example, we have engineering, science teams, evaluating, refining, writing these prompts, that kind of thing. In this case, we're actually having the agent do that itself. We'll continue the autonomy, increasing the autonomy from there. We'll talk about learning from interactions. So, memory kind of concepts with agents. We'll dig into that. And some more topics on further increasing autonomy. We've coined them meta agents, agents that orchestrate themselves. So we don't have to define, a graph, a workflow. They do all of that for us. We'll dig into that as well. And finally, we will productionize. We will deploy to agent core and show you how simple that is as well. We will save 5 or 10 minutes at the end for Q&A. So if you have questions, please write them down. We'll save some time at the end for those. And like I mentioned, we'll be available outside afterwards as well for further discussion. Okay. So over to Çağatay.
Let's jump. So starting with a basic agent is simple by design. We designed SDK for developers to develop their agents faster. For this case, we have a shell tool attached to the agent. And we are asking, what can you do? In this video, you can see I'm asking the question, and agent starts streaming to my terminal. This is the default behavior of Strands, but it only has a shell tool in it. With shell, agents can do access their environments they are running on. But I have a question. Can agents build their own tools? So we will be explaining that in a flash. We call them self-extending agents. So Strands hot reloads the tools from directory. Imagining like you are building a front-end service. You put a file, and framework allows you to load that file as an API. Same applies for agents. So I have a small code here. I want to highlight some points. I place a system prompt to the agent, which says, create a tool for yourself. That's the goal. Start using them directly. Because Strands allows hot tool reloading from directory, it can store a file under tools directory. In this case is weather, calculator, whatever you want. And the define the way the tool is add tool decorator, which we love and use. We attach that system prompt to our agent, but this is not enough by itself. We enable load tools from directory equals true, because with this way, agent will be watching the directory while you are developing your agent, or agent can write the file and test the tool for us, which we are just going to watch together. So let's see how agents going to create their tools and start immediately using it. One thing to notice here, agent will not going to stop after writing the files. You can see agent created a tools directory, which is empty, and using the shell tool, which is the only tool it have, to create some files. You can see the calculator handed, pathword generator, text analyzer, unit converter. This keeps going. But interesting thing is, after agent created these tools, it started using immediately. You didn't stop the process, and agent created these files 5 seconds ago. And now process finished. With this example, we show that agents can create tools during runtime and start using them. This is so critical for us and for the agents, so they can build their abilities on the fly. So, can agents update their own system prompt, Aaron?
Yes. So we just saw an agent that builds its own tools. Now we're going to look at an agent that updates its own system prompt as well. And we start getting into memory concepts a little bit now. Your agent being able to learn over multiple iterations. It's learning over time. So what we have here is very similar to what Shagatai just showed us. We have a system prompt. This time it's a little bit different. The system prompt's a little bit different here, right? You see the system prompt is actually coming from an environment variable named system prompt. And what this allows is it's a persistent storage for our system prompt, essentially. It's just an environment variable. But our agent, you might notice, not only does it have a shell tool now, it also has an environment tool. This allows the agent to read and write to environment variables. So we can say to our agent here in our system prompt, update your system prompt in every turn. Because it has the environment tool, it will go ahead and do that. And there are a few important steps here. So 3 important steps. We have defining our system prompt, which comes from somewhere that can be changed, like an environment variable. If you're deploying to production, perhaps, this could be any storage, right? It could be an S3 object. It could be a DynamoDB record, so that it's not tied to the compute environment, right? Like an environment variable. So you can store that somewhere else, load it, read it at runtime, and then you have persistent storage for your system prompt for the agent to modify. The second key piece here is we're reconstructing the system prompt on every invocation. So we first define our agent here, right? It does not have any system prompt. There's a system prompt parameter in Strands. There's not one defined here. It has no system prompt, just does whatever the model has been trained to do. We're adding this dynamic prompt here to our environment variable, and that is what we set as the agent prompt. And you'll notice every single time we're in this while loop here, we're reprovisioning the system prompt. We're resetting it, basically. So if that environment variable has changed, that will now go through into our agent here. And then finally, we invoke the agent. So three important steps. One is we define somewhere that the agent can read and write to, and then we reconstruct the system prompt on every invocation. We can see a small example of this here. So here's the environment tool we give to our agent, reading from some kind of persistent storage, reconstructing the prompt. Here we're resetting the messages. I'll show you in a second. So Shagatai wrote this. You can see here, my name is Shagatai Kelly. He's telling it that we're presenting session AIM426. That's this session here that you're all in. We send that prompt to the agent. So there we can see it's checking, it's called the environment tool. System prompt was not set. The agent has set the system prompt for us. So now we can go back to the agent here. We see it set the system prompt. We can ask a follow-up question, what is my name? And now it will say, my name is Shagatai. Well, my name is Aaron, but this is Shagatai.
I'm impersonating.
So here, it's a very kind of rudimentary form of memory, in a sense, right? And we'll talk about different mechanisms for memory. This is a kind of rudimentary form to introduce the concept. So now we have an agent that can change its system prompt as well. And what we did here is you see how we cleared the agent messages. This is the conversation history of the agent, all the interactions we've had with the agent, all of the decisions the agent has made, the tools it's called, the results of those tools. Those are all in that agent.messages property. We're cleaning them up in this example to show that the knowledge is not coming from the previous message I just sent, right? I said, my name is Shagatai Kelly. That goes into the conversation history. We're wiping that out to prove that it's actually getting that information from the system prompt, not the messages, which are now empty. So just an example of how that can apply to system prompts as well. So now we have a very basic agent, shell, environment tool. It's created some of its own tools in that tool directory. We've shown that it can modify its own system prompt. And now C2, Shagatai, can talk about what's going on behind the scenes.
So now we started with agent with one tool, shell tool, and we gave additional environment tool. Shell tool can also update environment variables, but let's talk about 3 steps Aaron mentioned. Dynamic prompt construction is the first step. So your agent system prompt needs to be allowing a dynamic part. Not everything in your system prompt needs to be dynamic, but there should be a portion needs to be allowing your agent to get the latest version of that system prompt. It could be a DynamoDB, it could be additional external resource you are getting your system prompt, but you need that portion. Second, self-modification. Agent needs agency to be able to update that portion for the future users. The third piece is persistence. You need to persist that version of system prompt in somewhere. So this is crucial for the agents and the sub-agents your agent will create so they can keep the context going. We will be talking about agents will create their sub-agents. Unless you store this version of system prompt, your sub-agents will not going to be aware of that changes. So, what if we ask agent a question today and expect that agent, that piece of context available for the agent tomorrow? I'm leaving to the Aaron to talk about it.
Yeah.
Here you go.
Yeah, that's good.
Sure.
So yeah, I'm just going to jump back a second as well.
Sure.
So this loop that we have here this is again about the prompt, but it applies to everything really, everything to do with these self-evolving agents. It's this three-step loop, right? You have the retrieval of some information, right? This first step, the dynamic prompt construction. We have the second step where the autonomy kind of comes in. The agent is able to modify its behavior in real time, maybe generating tools, changing system prompts, some other mechanisms that we'll talk about in a second. But that self-modification is what really enables the autonomy, right? It's not a static definition. Our engineers, our scientists have not defined, a big heavy graph with all these edge case handling, all this error handling, 50,000 different conditions that we have no hope of writing and covering all of them in a good way. So we're offloading some of the engineering and science burden to some of the models that are now capable of this orchestration, especially some of the more state-of-the-art models, Claude 4.5, GPT-5. Those kind of models are able to orchestrate themselves, essentially. And then finally, we persist that, right? So, for example, when it's writing tools, it's writing to a file system. Could also be, pushing them to GitHub maybe, for the modification of the system prompt here, for memory. It's again persisting that, right? We saw the example with an environment variable. As Chagatai mentioned, it could be DynamoDB, S3, somewhere to persist that. But these three steps are critical. So dynamic retrieval, modification, then persisting those modifications. And that's a loop, right? On the next invocation, the modifications that we just persisted are used. So it's continually modifying and evolving itself through every interaction. Those interactions don't have to come from humans. You could have an agent that is triggering self-modification on a schedule. It could be running triggered by events, perhaps. Maybe you even have an actor-critic kind of pattern where you kind of have an agent with another agent kind of battling it out with each other, correcting each other in an actor-critic kind of pattern. So to take that a step further, I mentioned towards the beginning meta-agent concepts, as we've called it. So we spoke about memory through system prompts. A few more methods for memory as well. Perhaps this is a more familiar method of memory using a vector store. So in this sample, we have a three-step process. We have, first of all, searching for relevant conversations and past context. So if that previous slide we saw, dynamic construction, dynamic retrieval, that's what's going on here in that first step. We're retrieving information from a knowledge base, in this case, Bedrock knowledge base. Could easily be any vector store, mem0, agent core memory, S3 vectors, whatever. We're retrieving that information and putting it into the agent's context. So that's that first step on the loop that we saw, the retrieval of modified information, things that the agent has modified, memories perhaps. Step two, the agent responds. So we invoke the agent. You can see here we have that result line. We're just invoking the agent. Because we previously called the retrieve line there, the agent has those memories from the Bedrock knowledge base pre-filled into its memory. We're doing a search on the knowledge base there, you can see with the user input. So if I type, what is my name? Our agent will call the retrieve tool that we've added here, which links to Bedrock knowledge bases. It will pass through my query, what is my name, retrieve some documents that we've stored in our vector store, our memories, what my name is, and those are pre-filled into the agent's context, which, as we saw earlier, is that agent.messages property. So by doing agent.tool.retrieve, I'm pre-filling that agent.messages context, essentially. I'm pre-filling the context window, pretty much. With Strands, when I call that retrieve tool in this manner, with a direct tool call, agent.tool, I can just programmatically call the tool there. It's pre-filling the agent's context with the results from that tool. So I can now have a workflow, as we see here, that's pre-filling the agent's context with my memories, just with that simple agent.tool.retrieve line. We invoke the agent on the result line, and then the final step, as we spoke about on the behind the scenes, is the persistence. The last line here, again, we have a direct tool call. This time it's not the retrieve tool, it's a store in KB tool. You can guess what that does. It stores in a knowledge base. And you can see the example document we have here at the bottom. The title of that document is conversation history, and you see the content here is what the user has asked our agent and what the agent responded with. So for every interaction with this agent, we are retrieving information from Bedrock Knowledge Base, pre-filling the agent's context, running the agent, and then storing the results in that same knowledge base. So when it runs again, the agent knows what we just did in the previous interaction. It's all stored in that knowledge base. There are, many different options for what you want to store in the database, in the vector store, right? Maybe you want to store every interaction like we have here. You can also give the agent those tools, right? You see here, we have the shell, the retrieve, the store in KB tool. So not only are we calling them directly in this workflow to pre-fill our agent context and enable continuous learning through memory with a knowledge base, we're also able to have our agent call those dynamically. So we do not have to program it even. We could, you could ask the agent a question, what did I do last Sunday, right? And it will dynamically call the retrieve tool and respond with that information. So that the agent is also able to, at runtime, dynamically call that tool, as well as me manually calling it. So yeah, here you have that retrieve, and here we have the store at the very end.
Can we ask questions?
Sure.
Yeah, sure.
Please do.
Which permissions are being used for the tool at the end, right? So you need IAM credentials or something like that to access the knowledge bases. Where does it take that from, this example?
So retrieve tool using Bedrock knowledge bases, and your agent runtime needs to have that IAM role. If you have that, that's just gonna work. But if you don't have that Bedrock knowledge bases ready, I would suggest to check Bedrock Agent Core memory, which is going to provision the memory for you.
But it's essentially, this is Strands comes with a suite of tools. We have that Strands tools at the top there where you see we're importing shell and retrieve. It comes with, a suite of tools that you can use. The retrieve tool here is for retrieving information from Bedrock knowledge base. We have other tools as well, right? Agent core memory, as Shagatai mentioned. You could use S3 vectors. You could use some of our partners like Mem0. We provide tools for that as well. There are MCP servers for memory, and each of those tools has their own authentication requirements, right? For Bedrock here, it's AWS credentials, right? So as Shagatai mentioned, it could be an IAM role. It could be, you type AWS configure in your terminal to set up your access key, secret key. That all works.
Can I ask a question here?
Yes.
So you say S3 vectors. So can an agent retrieve or look into multiple tools together, like
Yes.
Yeah.
S3 that go there?
Yeah. A couple of ways you could implement that. We could have, multiple retrieve tools. One that talks to our S3 vectors, one that talks to Bedrock knowledge base, as we see here. Maybe we have two Bedrock knowledge bases. So a couple of ways you could do that. You could either provide multiple tools, right? One per knowledge base, and your agent can dynamically select which to retrieve from. Another alternative you could do is you could actually bundle all of those, I think, into one tool, just like a retrieve memory tool, right? We have the retrieve tool here. In that retrieve tool, it's very simple. It's all open source. You can go look at the code on our GitHub repo. It's a very simple tool. You're able to modify that however you like, right? You could have it retrieve from S3, then retrieve from Bedrock as well, and combine the results into one. So a couple of ways to do that. It depends how you want to surface it to your model. It could be multiple tools or one that combines. Yeah. Okay. So we can see a short example of this running now. So again, Shagatai made this one. So do you know Shagatai Kelly? And it's responding information about things that Shagatai has worked on, because Shagatai uses this agent when he's working. So we know what he's working on here, and has given us a nice little bio about our good friend Shagatai here. And this is your typical memory kind of integration, right? These are documents in a knowledge base. Our agent is able to use them. Simple as that, really. Okay, So I'll hand over to Shagatai again to talk about further increasing autonomy and agency with meta agents.
So far, if you are following along, this is the place we will be discussing about how we can increase agency. Because we gave an agency so far to update their system prompt, their own tools, learn from every turn, but we didn't talk about the steps, which we will be explaining here. The building their own tools is one level of agency we gave them. The second level is creating agents dynamically. The main agent you are running can create their own sub-agents with custom system prompt, custom set of tools, and they can be async. Your main agent can trigger one, leave it running, collect the results later. It could be a sync, trigger the agent, wait for the result, and get the result. But we have additional agency we are not going to touch today. Agents can update their own Python code and continue running, which is possible.
That second point, I think, is particularly interesting. The creating agents dynamically. We've seen, research papers from Amazon and Anthropic where we have a research agent that Anthropic have published, for example. There are predefined agents in there, right? So we're taking that a step further. We're saying to our orchestrator agent, our main agent that we're talking to, we give it a tool that allows it to create another agent, a sub-agent, dynamically. And none of our engineers, none of our scientists have defined what that agent is. We haven't given it a system prompt. We haven't given it tools. We're able to dynamically create them. So our model itself is deciding how it needs to break down the task, what sub-agents might be ideal, right? It's like if you're managing a project, right? You might know what kind of skills you need to work on that project. That's what the model is doing here. It's figuring out what skills it needs. It knows what tools are available for the agents, and it can dynamically create them. And again, each of those sub-agents could also be self-evolving, perhaps.
Maybe it's a great time to give an example for this. To imagine your agent have a tool named use agent, right? And that agent tool will accept system prompt, tools, model provider, and model settings as parameter. So let's see that. In this example, I attached a couple of tools to the agent. Shell, use agent, think, swarm, graph, and journal. So let's talk about it before we start running the video. Shell tool we all know, it's perfect. It's access the environment. Use agent have ability to create a new sub-agent, which is another agent interface. You invoke a brand new agent, which accepts system prompt, tools, model settings. That can use a different model provider. Could be Anthropic, could be Google, could be Bedrock, any model provider you would love. And accept additional tools. Because your main agent in this case, Shell, use agent, think, swarm, graph, maybe your sub-agent don't need that in the first place. So you can see there's a think tool. In other agents, you can see ultra think, deeper thinker, whatever. You can count that. The idea behind the think tool is we are calling one agent, and the result of that agent passed through the second agent, and then the other agent until n number of times.
It's like recursive thinking.
Exactly.
Yeah.
So we are allowing agents to create their instances programmatically n number of times to deepen that idea throughout the time. We have a swarm tool, which is a shared context between agents. Aaron have a great example for this. We collaborated on this presentation. Do you want to take some time to explain?
Yeah. So Shagatai was just talking about some of the meta tools that we have, right? So use agent, think, swarm, graph. Swarm you can think of as like a self-organizing team, of agents, basically. So the example Shagatai was giving, him and I have paired, brainstormed, sat together, pens, paper, PowerPoint, IDE code to make this presentation. I wasn't telling Shagatai what to do. He wasn't telling me what to do. We were just two peers collaborating. It's kind of what a swarm is, right? There's no lead agent. That's just a collaboration of agents, and they figure it out among themselves. Super interesting concept. You see similar things in frameworks like Crew AI as well.
So thank you for that example, because today we were talking about that, and we have a great diagram in a couple seconds. So we have a graph tool as well. This is for conditional edging. You can define a group of agents are directed to each other. And the last pieces of this is journal. Journal is using a file system to persist data, so our shared agents can have a backbone of context. It's more of an agent scratch pad.
It could be like a to-do list for your agent, right?
Exactly. If your agent starts working on something, they are not losing the context about each other. They will be all aware on the same context. So let's see. In this example, I'm saying use agent tool. That's it. I'm not prompting. I'm not doing a lot of prompting. It's ask me what to do. And I'm saying testing use agent tool. I'm not giving any hint to the model. It says, okay, I'm going to use agent a couple times. I'm going to calculate 2 plus 2. This is the best thing to do, right? And main agent invokes two different subagents to do two different things. But so far, what we achieved with this ability, we expanded our context length. Because our main agent had 1 million context length in this example, but every subagent agent created have a brand new context that can spend 1 more million, and they can call each other to spend more. So here is the diagram we have been all trying to put together. In this diagram, we have create subagent tools called 4 times in parallel. Agent invokes those tools in parallel and not waits to see the results. It is fire and forget pattern. The main agent going to be idle after this step. On the first row, we have one agent uses another agent. That use agent have 1 million context length again. And that creates 2 more those in parallel. But it's going to wait for the results. And this result going to be get back propagated this agent. So this agent going to store the result in a journal. So this row going to spend 1, 2, 3, 4 million tokens in the worst scenario. If you keep everything running for a long time, you expect at least, at max, 4 million tokens you are looking at. So the second row is the thing. We just mentioned like recursively calling the agents and share the context across the time, which is this.
I liken the think tool to, if I'm doing research on a topic, I'll do my initial research, write it all up, and then I kind of do the same again, right? I like refine my understanding maybe a month later, right? I'm revisiting what I just did. It's kind of what the think tool sort of does. It's you invoke the agent, it does something, and you kind of get it to do it again, right? It's like think deeper. And in this example, we have it thinking 10 times to show the case, right? But maybe you only want it to revise 2, 3 times.
So, yeah, go ahead. Yes. You asked, there's a journal tool. What is the difference between?
Yeah, how is journal and memory
Journal
different?
is using a file system here, so there is no extra dependency. Let me go back 1 second for that. I think I'm unable to go back.
I got you.
Thank you so much. Can you go one more back?
Yes.
So maybe okay. I'm just handling it. So this journal tool only using the file system. So there is no memory or any other thing happens here. If you plug the Wi-Fi off, this agent's still gonna work because of that. Yeah, but they will be eventually consistent.
I think a nice difference as well, I guess, is, and it depends, right? There are many ways to implement memory. What we saw previously with Bedrock knowledge bases, S3 vector, agent core memory, mem0, those are vector stores, right? They're based on embeddings. You can do semantic retrieval. The journal tool here is markdown file based. It's another way to store memories, right? You can have markdown files of memories. It limits your ability to do semantic search, right? You can't, it's not embedded at that point. So yeah, a couple of different ways to implement sort of a mechanism for your agent to kind of track progress, right? Which is a form of memory, yeah.
And in semantic search, there's a delay once you store that context and how that's going to be propagated back to you. In this case, time is crucial for us because one another subagent going to be triggered immediately. You may not going to be able to wait that ingestion finishes.
Yeah, we've experimented a lot as well with things like, ChromaDB to run like a local vector store as well, super fast, like a couple of milliseconds to run, which helps with some of the latency stuff that Chagatai mentioned. But then you have the trade-off of, well, now it's not distributed, right? If the compute that is running on disappears, that's gone, right? So it's, yeah, a lot of different trade-offs.
So we were mentioning this swarm by context sharing each other. In the swarm pattern, we have a small circles have an intersection between. That's the context we are trying to explain. They have a shared context about each other, and while they are working, they will be keeping their context in their boundaries in case of
and this shared context can be implemented many ways. In our example swarm tool, we've implemented it in memory. So as this context is being, agent 1 updates the context, agent 2 updates the context. Well, now agent 1 and 2 are able to both get both of those contexts, right? So they're able to almost communicate with this shared context. It's, as Chagatai and I were working on this presentation, right? We wrote down a bunch of notes, right? This is our shared context in memory. Same idea. It doesn't have to be in memory either, right? The shared context could be any sort of storage, right? It could be DynamoDB, whatever you want as well there.
So after swarm, we have a graph on the last row. You can see these are the directed systems. You can actually make them loop again. They can stop whenever the task is finished. But there's an interesting thing. We have below here the graph node, one of the graph node using use agent. What is that?
Yeah, so you're able to compose these like primitives, these orchestration primitives, a graph, a swarm, use agent. They're all able to be mixed and matched. You can have a graph of graphs. You can have a swarm of graphs. You name it. They're all able to mix and match and compose with one another as well.
When agent is running, it can change the way it's running. We are leaning towards the model-driven approach. The models get better. They are getting better to create this kind of such systems, never being visible or explainable for us. This is something beyond static than our workflows. We have been building all. Shall we?
Yes.
Intelligence is ability to adapt to change. The reason we are building software to help people, it's not supposed to be static. And the way to do that might be agents, might be robots. We will all see it together in the future, I believe. Do you want something to add?
No, that was great.
Okay. Let's deploy.
Yes, so
we have a video here of our code. We changed the way we code previously. We let the agent update their system prompt, build their tools, right? But we need to deploy this to somewhere else on cloud because I don't want my MacBook keeps open forever, right? So you can deploy your agent to any runtime with Strands. But in this case, we are going to deploy to agent core. To deploy to agent core, 3 different CLI commands and 1 decorator you would remember. The decorator comes from Bedrock Agent Core Python package, and I am importing the memory primitives from Bedrock, so my agent will be able to learn from every interaction after we deploy. In our local, we were using Bedrock knowledge bases. When we are deploying to agent core, I switch to Bedrock Agent Core memory. And I attach a session manager to my agent, so every session, every turn, going to be part of my context of my agent. So I can ask a question as a blocking, fire and forget, and streaming way. These are the 3 different options when you're invoking an agent. As we mentioned, like a create a sub-agent, that's fire and forget. So I'm using agent core launch CLI command to deploy my agent to agent core. This is provisioning the memory and knowledge base for me. It's immediately useful after this line of command finishes. And I'm running agent core status to make sure my agent is deployed. And I'm using agent core invoke to invoke the agent.
We see how fast that provisioned as well. So I guess the point we're trying to get across here, we've built this great, self-evolving agent, built its own tools, can modify its own system prompt, it has memory, it learns from our interactions. Now we need to ship it somewhere so that we can turn it into a business maybe, start making some money perhaps. With a simple 1 decorator, you just do @app.entryPoint at the top of a function, and now it's an agent core agent, right? Now you can deploy it to agent core. And as Shagatai showed us, we can run agent core launch, and that does everything for us. And as we saw, that was a real-time video, not sped up, that was provisioned everything. And now it's infinitely scalable, running on AWS in a serverless manner, paid per request.
So far, we deployed our agent while I was talking. That might be fast from the vision, but let's try. I think we have some resources.
If we jump back just 1 second.
Yeah.
I wanted to show here, let me play this.
Do you want to show the code?
I'm going the wrong way. So if I play this again.
Okay.
So yeah, 2 SDKs. We have Strands. Bedrock Agent Core has another SDK. Python, TypeScript, you name it. We just launched Strands in TypeScript today, if you're interested in that kind of thing. But here you see that entry point, right? It's a decorator. We just have app.entryPoint. Once we have that, we can just run those CLI commands. Agent core launch, agent core invoke. We've also just upgraded the agent core CLI this week. Encourage you to go and play with it. You can also run agent core dev. Does the same thing as agent core launch, but locally. So it puts your agent into a container that matches the same input-output interfaces as when you have had it deployed, but just running locally. If you've built Lambda and you're using SAM CLI, similar kind of concept where we just containerize your application here with like a local dummy version of agent core runtime essentially, but it works exactly the same way as when you deploy it as well.
So far, we have been explaining advanced topics. We expected agents to build their system prompts, their tools, and maybe it's hard to keep up with everything we explained today. I would suggest to check it out our GitHub resources on our GitHub organization named strandsagents.com as well. So let us know what we can do better, and let's build together.
Yeah.
So I'm leaving a couple more seconds to take some photos.
Yeah, and you see there's a few links here. Like I mentioned, we just launched TypeScript as well for Strands. We just launched an evaluation
Bi-directional
SDK.
agents.
An evaluation SDK for Strands. Yeah, we launched a bunch of features. There's bi-directional voice agents we just launched today as well. So you can now talk to an agent in real time. It can understand intonation, rhythm, if you're stressed or happy, that kind of stuff. And we also introduced a new concept called agent steering. So if you go to the strandsagents.com website, that third QR code there on the right, you'll see on the navigation menu in our user guide a section called experimental. If you go into there, you'll see some of the new stuff we've just launched, like the bi-directional voice agents, agent steering as well, which is super interesting. It's more of that actor-critic kind of pattern. We're applying a lot of that stuff into Kiro as well, if you're familiar. Kiro is built on top of Strands, and everything we're showing you here today powers Kiro as well.
So the best way to predict the future is to invent it. Here we are at reInvent. I hope you are enjoying this meeting so far, and thank you for joining us. We have a Q&A session for 15 minutes. We have a great time to chat and explain all the questions we have. And yeah, we have some resources as well. We will be keeping this open, and we are here to answer your questions. Yeah, go ahead.
So this is all like a bit abstract.
Yeah.
Do you have like a practical use case that you think is exemplified by these tools in action?
Yes, we have beyond that. We have beyond examples than you can just install right now on your computer and test these all features and beyond. We have an agent, it can update their own messages. It can remove the tools from the list of tools and everything. We can talk after this. I can share with you directly, or you can visit the Strands Agents agent builder. You can give it a try by yourself.
Some use cases we've seen, research agents, very beneficial here. I think where you're looking for, I personally find it useful for two things. One is where you're looking for emergent behavior, and the second is where the problem space is so big that it's infeasible for me to engineer it, right, as an engineer. Say, for example, developing something like Kiro, right, or QCLI or something, or Claude Code, right? Those tools being able to extend themselves with, LLM intelligence, we found to be very useful. For example, now Kiro is able to write its own tools, right? If I say, where is the space station, right? How far away is the space station from me? There's no tool for that, right? But the agent is able to build its own now. And, I work at, maybe I work at NASA, right? Now Kiro is able to use, my internal APIs or whatever to find where the space station is. So I personally find it useful for two things: emergent behaviors, and one where the scope is so broad that it's like I'd need a big, expensive team of people to engineer that. That's where we found it useful.
We have 2 more questions? 3 more?
It seems useful to talk about the converse also. Where would you not want to create agents that self-evolve? It seems like a huge liability space, so do you have anything to say about that?
That's a great question.
Yeah.
Leaving to my principal engineer.
Yeah, so I just mentioned we just released this steering concept. And you'll find as well we just launched agent core policies, right? And as you mentioned, these models are stochastic, right? They're not deterministic, which is beneficial actually. But what we've built with agent core policies, I encourage you to go try it, is it's adding some more of that determinism to these agents. So we have these very powerful dynamic agents. We kind of want to draw a box around them and say, this is your boundary, right? You can evolve and self-modify, but only within these constraints. And those constraints can be defined in many different ways, right? You can try to write a bunch of if-else statements, but then we're back to the same problem where I have to engineer this huge scope, right? I can build a state machine to validate everything the agent's doing, but it's unwieldy. So with agent core policies, encourage you to try them, you're able to type in natural language and it will generate a policy for you. Very similar to an IAM policy. It's built on the same language. It uses Cedar, our open source library for this kind of thing, for policy language. And you're able to define deterministically what the bounds are of that agent, right? Those bounds can be literally anything. And the policy is able to be formally proven using some of our automated reasoning techniques. You don't need to deeply understand automated reasoning, right? We have a natural language input there. You write natural language, it will generate the policy for you. That policy becomes kind of the source of truth for the bounds of the agent. But yeah, definitely encourage you to try that.
The critic part is policies are outside of the agents. They are not inside of the code base. So even they evolve, there is nothing to do with that. Please.
I was in the session before talking about the design of Agent Core.
Yeah.
And one of the things they mentioned was that your container, let's call it,
Yeah.
was for the session.
Yeah.
So if I write these tools, they're not persistent. Have
Uh,
you thought about how to do that across Agent Core?
That's a perfect question. You can store your tools in an S3 bucket and let other agents to download and use it, but there are many ways to do that. I'm taking...
Is there just like a checkbox in Agent Core to say, share this, point this subfolder to...
That's a perfect idea. I will be working with the team to make it possible, like a persist environment. We will be taking that feedback very carefully.
Yeah, there's a couple of things on Agent Core. The runtime, it's a long-running container, right? You can have a long-running autonomous agent there, but you're right, it's a single piece of compute, right? It's a container, essentially. Under the hood, it's a container.
Yeah.
So it's ephemeral, right? It's a container. It might be long-lived, but it is ephemeral ultimately. So as Chagatai mentioned, it's back to that topic, right? When these agents are evolving themselves or modifying themselves, we need to persist it somewhere. So it could be S3, it could be wherever, right? And in the example we gave, if you, I'll share the link again in a moment to that repository. If you clone that repository, if you change the system prompt to write your tools to S3, and if you give it the Strands use AWS tool, it will write those tools to S3, as an example.
I think the Docker container needs to be persisted in a way. We can just reuse the same environment as is, but that's definitely we will follow.
Reinitializing like the whole container state, like all of the memory is something we're looking into, yeah.
There are ways to export to Python runtime, but we can talk later.
So how an agent decides like whether it has to create agent or tools? Like what are the criteria? When to create tools or when to
We are picking the model-driven approach, so we are not determining what to do in when. So we are letting the agent have those tools, and models are deciding to use it or not. I hope this answers.
Like, let's say a human is created right now. So what are the criteria someone has to decide? Whether should I create a new agent or should I create new tool?
It's completely based on the request you're asking. My manager was asking, should I buy an AWS stock today? Do we need to create a new tool for that? Definitely not. But agent created 5 different sub-agents to make the market research, check the Strands Agents documentation, right? So it's basically depends on the question. I hope this answers. I have a gentleman here.
Can you talk a little bit about production deployment of these agents? Because I would not use the agent core CLI to deploy to production. Right?
Yes.
Yeah.
Yes. Very good point. So we built the Agent Core CLI for developers, right? Same reason we built Strands, actually. Developer experience first. People are not going to use Agent Core if it's not easy to use. We understand that. So we built Agent Core, the CLI, for that purpose, right? I'm a developer. I want to quickly deploy it. And we've actually been surprised. There are a number of companies that do deploy to production that way, which is interesting. But you know, on the more perhaps traditional side of deploying this to production, Agent Core has support for Terraform, CDK, right? You deploy it through your typical CI/CD kind of thing to production as well.
There is one gentleman. I will take you. Yeah.
Oh, yeah, I was just wondering, like, I mean, have you tried using like a self-evolving system on any real-world examples?
Can I repeat the question again?
Oh, yeah, have you tried using the self-evolving system on any real-world problems?
Have we tried using the
Yes.
self-evolving agents on real-world?
Yes, I can give you one example. As a research engineer, I built a research agent for myself, running on GitHub every day on schedule, keeps evolving on system prompt, and searching in Arxiv for finding new ideas for me.
New research
because
papers.
A lot of Arxiv paper are releasing every day, and I cannot keep up with. What I did is for myself around 2 years ago, deploy my Strands Agents to GitHub, but we were internally using the Strand back in the time. So it keeps searching the archive, using the cross-ref to compare the papers, and sends me a Slack message every day. I just read the post every day, and itself of agent build those archive tools, cross-ref tools, and whatever you can imagine from that point. I have another repository similar to the research agent, but it's for building tools. It's building the tools for protocols like a TCP, WebSocket, and more. I didn't want to spend my time to keep building tools. I just built an autonomous agent to build that for me.
I've found it useful for, like, for example, we have Kiro CLI, right, formerly known as QCLI. We have an internal version of that implements a lot of this kind of style of agents, right, a self-evolving agent. And it's just my personal assistant, essentially. I don't want to have to code it and prompt it on how to do research and coding and testing and X and planning my weekend, right? It's basically my personal assistant, and I don't want to define all of those because there's like 1,000 things that I do. By enabling it to evolve itself, I don't have to program everything. I'm relying on the model to define that. Obviously, I'm doing human in the loop there, right? I'm reviewing what it's doing. I'm looking at the tools it's generating, that kind of thing. And obviously, you can evaluate these agents as well, right? Every time they make a modification, you're able to run evaluations. Like I say, we just launched Strands evals, agent core evals. That's one method there as well.
There was a gentleman.
First of all, I think super cool is the novel, so congratulations if you guys built this. It's more of a common-sized question. The entire immutability artifact deployment paradigm goes out the window, right? Like whatever you tested or not, it doesn't matter. Because whatever gets deployed, who knows what that is, right? So I kind of want to get your thoughts on that. Like, testing this becomes effectively impossible, right? You don't know.
No, I wouldn't say it's impossible. I would say, I think the points that you run those tests changes, right? Like instead of everything happening, and the scope of those tests changes, right? Like my deployment tests here would essentially make sure it deploys, and whatever functionality it had previously still works. As it's self-evolving, I would then test it again, for example. Like every modification it's making, test it again, pretty much. And that's I think, the human in the loop portion.
I have a great answer for how we can actually evaluate these such systems. When we gave an agency to the people, not the agents, just skip the agents for 1 second. We gave an agency to a people. We need another people, a same agency, to compare. Why we are not thinking for the agents the same idea? You build one autonomous agent to do something. Build similar one to test it. Because these are the systems we use to actually improve one of other, right? That's the place these such systems can evolve together. Instead of trying to predict what it might happen. Yeah. We will see what it will happen.
And there are definitely certain use cases it's appropriate for, and some that it's not, for sure.
Okay. I think it's inherently stochastic.
Mm-hmm.
Yeah.
Like to your point about humans, well, we don't always test the humans. I think the humans build trust over
By time.
a period of time, right? So presumably that's the approach you're taking.
Yep.
Yes.
More philosophical, I suppose, right? Like, well,
The-
this thing has done things for me past 9 times, whatever, unleash.
Mm-hmm. Yeah, it's kind of like these agents are almost like learning by interacting with the world, right? They're living in the world with us, doing things, and like they build a tool that calls an API, they test it, it fails, they modify the tool, now it works, right? At some point in that chain, you probably want a human to review, but where you do that, it could be, immediately, at every step, at the end, after a month, right? You have a lot of options there, but definitely human in the loop still for certain use cases. For some of the other use cases, like these personal assistant tools that we've built, I actually want it to just go and do everything, right? So.
But you could have it write specs and say, I want to call another agent that
Yep.
builds this, another agent that checks it, another agent does security checks, right? Have a chain of stuff that all of them have to sign off before the tool's added to this shared directory.
Absolutely.
Definitely.
Right? You can do a lot of the automation of what we do today.
Yeah. Definitely.
Really simple
Python SDK helped us to build TypeScript SDK, and we will be building rest of the SDKs all together. We initially built the Python SDK for internal reasons, like 3 years ago, and it's became something publicly available today. And lots of our customers ask us TypeScript to have, and we launched the experimental version today of TypeScript, and that SDK built by the Python SDK running on GitHub.
Yeah, if you go check out the TypeScript repo on our GitHub org, look at the pull request, look at the issues. The agent built that SDK, and you can see we didn't just YOLO, right? It's human in the loop. So if you look through there, you can see our engineers working with the agent to build it, and it saved us a significant amount of time. But the idea with the different languages, and we're also talking about more languages, the idea is that they are at feature parity. Today, TypeScript is V0, kind of preview release. Python has been V1 for a couple of months now, but the idea is we have feature parity.
Yeah, are you planning on using like what they use for the SDK, like JSII, transcode between them, or?
Today, they're developed separately. So that we
Separately.
can make the most use out of each language features and the ecosystem, yeah. But it's something we have spoken about at length, yeah.
So before we left, I will take one more question, right? And we would love to give you some feedback after this session. We would love to see your ideas, and this is critical for us to evaluate are we done in a good way this session. Please check it out in your AWS Events app. So give us some vote. We have one more question.
I was kind of wondering if you had any best practices regarding the memory, because it seems like collisions, duplication, I mean, it just kind of seems a little bit messy really quick.
So semantic indexes are basically collapsing the data in a 3D environment, right? And that environment might be having the same context over and over and over again in that regard. So the way to store the context and how to retrieve it is basically the engineering problem we are all going to be solving. If you are storing the conversation history in the same place, you may need another knowledge base to attach additional context, so they're never going to be overlapping each other, right? This kind of engineering decisions we are all going to make from further as an agent builder persona.
Okay, thank you everybody.
Thank you so much.